This facility produces one of the world's most powerful battlefield weapons, rocket launchers.
Every person and material entering is logged under strict military security protocols. The process begins with high-grade steel, transported under constant surveillance.
These steel tubes will later form the structural backbone of the launcher. Temperature and humidity are carefully controlled to prevent metal fatigue. Each batch is tested to match precise military-grade alloy standards. Computer-controlled cutters ensure uniform length with millimeter-level accuracy.
High-powered saws slice through hardened steel in seconds.
Automation reduces human error and speeds up production safely.
Precision drilling prepares the internal structure for later chamber alignment.
Lathes refine internal surfaces for smooth projectile travel. Every dimension is verified manually, despite automated manufacturing. Heat strengthens the metal to withstand extreme launch pressures.
Controlled cooling prevents warping and microscopic fractures.
Non-destructive testing reveals invisible internal defects. Even the smallest flaw leads to rejection.
Faulty materials are destroyed to avoid any battlefield failure.
Only perfect components move forward in the production chain.
Surface preparation ensures strong adhesion for protective coatings.
Specialized coatings protect launchers from rust in extreme environments.
Drying chambers maintain consistent curing conditions.
Manufacturing now shifts from raw materials to weapon assembly.
Firing mechanisms are assembled in isolated safety zones. Each component must respond instantly without mechanical delay. Springs are stress tested for thousands of simulated activations. Redundant safety systems prevent accidental activation. Structural frames provide balance and firing stability.
Every bolt is tightened to exact torque specifications.
Recoil management protects both operator and weapon integrity.
Aiming systems are aligned using laser-guided calibration rigs. Accuracy depends heavily on precise optical calibration.
Modern launchers often include electronic firing assistance.
All wiring is shielded from heat and vibration. Launchers must operate in rain, dust, and extreme cold.
Internal pressure tests simulate real firing stress. Data ensures each launcher meets military endurance requirements.
Only certified units receive military acceptance labels.
Tactical coatings reduce reflection and visual detection. Each unit is painted according to deployment region.
The outer layer resists wear and chemical exposure. All components now converge into a complete weapon system. Rear blast protection is critical for operator safety. Comfort and control directly affect firing accuracy. Each launcher receives a unique, traceable identity.
Independent inspectors certify operational readiness.
Mechanical functions are tested without live ammunition. Live tests occur in isolated, reinforced test ranges.
Machines handle test firing to eliminate human risk. High-speed cameras analyze projectile exit behavior. Each test confirms alignment, stability, and ignition reliability. Engineers analyze every frame for micro-deviations.
Recoil values must remain within strict safety limits.
Only fully verified units proceed to packaging. Final servicing ensures smooth field operation. Shock-absorbing packaging prevents transit damage.
Each crate is built to withstand extreme transport stress. Humidity control protects electronics and metal components.
Security seals prevent unauthorized access during delivery.
Finished units await deployment under armed supervision of an elderly East Asian female security guard.
Delivery is coordinated directly with defense departments. Digital tracking monitors every launcher worldwide. Transportation follows secure, classified routes.
Global supply networks coordinate battlefield distribution.
Each shipment is monitored in real time.
All movement is legally documented under international regulations.
International deliveries involve layered security clearances.
Operations often occur under strict time windows.
Weapons are issued only after final verification.
Field engineers perform acceptance checks again.
Proper storage preserves long-term operational readiness.
Soldiers train extensively before live deployment.
Execute evasive maneuvers now.
Simulation reduces battlefield errors and casualties.
Field tests validate real-world performance conditions.
Each soldier learns balance, aim, and recoil control. Safety protocols are reinforced at every stage.
Heat dissipation protects structural integrity. Wear analysis predicts long-term durability. Field maintenance readiness is equally critical.
Spare components ensure long-term serviceability.
Every launcher has a lifetime performance log.
Commanders rely on verified technical performance data.
Nations store weapons across hardened underground networks.
Temperature control prevents long-term material degradation.
High-value weapons remain under constant protection.
These systems are deployed across multiple theaters worldwide. Old units are dismantled under strict supervision. Even retired weapons return to raw material form.
The factory never truly sleeps, operating around the clock.
From raw steel to battlefield power, every step is engineered for precision and control.
The final movement begins. Egenin.